Alright, in problem number 3, we're asked to find the sum of these cubes from 1 cubed all the way up to 15 cubed. Now, you could probably do that on a calculator, but I told you not to use calculators. So if it would be a pretty tough problem to do, or, well, it wouldn't be tough, but it would be tedious to, cube all of these numbers and add them up. You could do it. It would take some time. But in order to make this simpler, let's look for a pattern, okay? So we know that 1 cubed is just equal to 1, right? So let's look at what 1 cubed plus 2 cubed is. So that's just 1 plus 8, which is equal to 9. 1 cubed plus 2 cubed plus 3 cubed. Oops, 3 to the 6th. How did I get that? Alright. 3 cubed is equal to what? It's just 9 plus 27, which is 36. And I'm already seeing, I'm seeing squares, right? I'm seeing 1 squared, I'm seeing 3 squared, I'm seeing 6 squared. Well, let's keep going and see what else we can, see if that pattern holds. So, 1 cubed plus 2 cubed plus 3 cubed. Why do I keep reading 6? Okay. 3 cubed plus 4 cubed is equal to 36 plus 64. That's 4 cubed, and that's equal to 100. Another square. Alright, let's look at this pattern. We have 1 squared, we have 3 squared, we have 6 squared, and we have 10 squared so far. So, a pattern. Well, when you've got some experience with these types of problems, you might recognize these as being triangular numbers. 1, 3, 6, 10. So a triangular number is just one where it's basically the sum of consecutive numbers. So this is the first the first triangular number is just 1. The second triangular number would be 1 plus 2, which is 3. And the third triangular number will be 1 plus 2 plus 3, which is 6. Okay? Keep going, you add 4 to the next to get the next triangular number, and that's 10. Okay? So you may or may not recognize that, but you can see a pattern, I guess. You could see, well, it looks like you add 2 to go from 1 to 3. You had 3 to go from 3 to 6. You add 4 to go from 6 to 10. So you can see that you're adding consecutive numbers each time. So there's a pattern there. So if this pattern holds, then it really looks like the sum, the sum of cubes is equal to the square of a triangular number. Okay? So, what would be the 15th triangular number? So in order to get 1 cubed plus 2 cubed all the way up to 15 cubed, we'd have to figure out what the 15th triangular number is. So the 15th triangular number would just be, if we follow this pattern, it's just 1 plus 2 plus 3 plus all the way up to 15, right? Because you can see the 4th triangular number is 1 plus 2 plus 3 plus 4. The 5th triangular number would be 1 plus 2 plus 3 plus 4 plus 5. Okay, so if we add the numbers 1 through 15, that will be the 15th triangular number. So this is the 15th triangular number. That's this. Alright, so we we can figure out what that is. Now, if you know the trick, there's lots of tricks in this problem. You can add those up. I mean, it's doable. Um, but the trick I like to use is essentially it's Gaussian addition. It's Gauss's way of adding. So, you know, if I had this is plus 14, you can see that the first number and the last number add to 16, and the second to last and the second number add to 16, and so you end up. Here's what you do: you add the first number and the last number, which is 16, times the number of numbers, which is 15, and you divide it by 2. Okay, so it's essentially 8 times 15, which is equal to 120. Alright, so this is the 15th triangular number. And if our pattern holds, then the sum of the 15 cubes here should be equal to the 15th triangular number squared. So if we square that, this is essentially 12 times 10, and if we square that, it's equal to 144 times 100, which is 14400, 14,400. Okay? So that is actually the answer. 14,400 is what you would get. And you can try it on a calculator. You can put it in a spreadsheet if you want, or whatever, and see, check it and see if you get that. But it does hold up. It is true. But it's interesting, and it is true that the the sum of the cubes, so the sum of n cubes is equal to the square of the nth triangular number. Okay, so that's a really interesting property. There's a couple other properties that are interesting too. Like, for example, if you look at the squares of numbers, they are actually equal to the sum of odd numbers. Okay? Oops, what am I saying? I'm getting ahead of myself here. So 1 is equal to 1. That's kind of trivial. 2 squared is equal to 1 plus 3. 3 squared is equal to 1 plus 3 plus 5. Okay? And so on. So you can add the odd numbers and you will get a square. Another interesting fact is that a cube of a number is equal to the sum of consecutive odd numbers, but 1 is equal to 1. 2 cubed is equal to 3 plus 5. 3 cubed is equal to 7 plus 9 plus 11. Again, you've got consecutive odd numbers, but they're different. So you have the first odd number is equal to the first cube. The second and the third odd numbers is equal to the second cube. And then here you have 3 odd numbers. So essentially, I guess this is the 4th, 5th, and 6th odd numbers is equal to the third cube. So another interesting property. And so see what you can do with those. And you may be able to actually prove that the sum of the n cubes is equal to the square of the nth triangular number. So there you go. Interesting number facts.